All right, so this was again a very, very, very nice track today. So, as you remember, we started here, and with the island B, we moved up here. And also today, very fantastic view and great weather. So let's have a look at what we looked at. So we looked at VLAN Layer 3, the Internet Protocol. And there we especially looked at the basics of IPv4. We looked at IPv6. We looked at the differences of the two. So we looked at different address formats. So this one has longer addresses with different notations. This one has the shorter addresses. But in principle, they have the same purpose. So you want to address hosts across the internet. So when you remember in the part 1, we looked at addressing hosts with the MAC addresses that are neighbored. And so now with layer 3, we want to go through multiple hops. Okay, then also difference. This one has a variable header length because there are options inside. This one has the options separate. And also the IPv6 has automatic configuration mechanisms, which we looked at also. And so it's the newer version of it. We looked at addressing, we looked at subnetting. So there you can remember again. So it's like when you send a parcel and it gets to a delivery hub. And in the hub, they have to decide if they want to send it to the US, if they want to send it to Africa, if they want to send it to Australia. And this is what the router does. So it takes the information that it has about the subnet, so the different parts of the internet, and uses this one for the forwarding decision, so where to forward. We looked at the auto configuration I was mentioning before. We looked at the stateless address auto configuration, where the UI64 is used for generating the host part of the IPv6 address. We looked at different prefixes for the link local and for the globally unique IPv6 address. We looked at different supporting protocols, namely the neighbor discovery protocol that is used on the one hand to find out if we have duplicate addresses, and on the other hand it's used to do the resolution between the layer 2 address that is still required for doing this one hop thing here. So we always have to find out the next layer 2 address of the next router to do the forwarding there. And at the same time, we use the NEP for that, and also for the duplicate address detection. And we use the ICMP v4. So there we looked at that it can send us problems back. It can report us, for instance, that the packet is too big and we have to fragment it. And there we've seen that then the starting host has to fragment the packet so that it travels through the entire internet to the destination. What else did we look at? So we looked at the differences in the addressing here I was talking about before. We looked at the routing versus forwarding, which I was talking about before, namely this one being exchanging where to send something, and this one then using this information to take the decision where the actual packet should be forwarded. We looked at the fragmentation, and we also looked at the static routing. And the static routing was when we have such nodes here that decide where to send the packet next. They need the information where the next directions could be and which subnets should be forwarded where. And here we looked at how we can statically configure that. And with this knowledge, you actually know now how packets can travel through this entire internet. And this is quite nice, isn't it? So we only had 2 parts, plus the 0 part for the introduction, and you already know how the packets can travel from one point in the world to another part in the world, just using the components that we looked at. Fantastic. But for the real internet, this mechanism does not scale because we have too many hosts. We have millions of hosts there. And if you would have to configure everything by hand, so imagine there's new hosts joining, new providers, changes because parts of the network are breaking down and so on, this would not scale at all. So you would need so many people and it's so much error prone that we have to automate this mechanism. And this is exactly what we will do in the next part. So let's have a look at that. So in the next part, we'll look at routing again. And there we'll check again routing versus forwarding. We will look at routers and hops. We will look at the longest prefix matching. So how is this decision actually taken in the routers? Then we will look at different algorithms for automatically determining shortest path between 2 points in the internet. We will look at cost metrics. So if you want to do forwarding now, how do you decide where to put it? Because it could be that between 2 points in the internet there are multiple paths, and you have to decide which one to choose. And as a teaser already, so typically you would choose the shortest path, but it's unclear what this shortest is. Then we look at routing loops, because of course the internet is something that has many connections, and it could easily be that a packet is getting into a loop and then it's traveling there. And if it would travel forever and this happens to many packets, then the entire internet would not work anymore. And therefore it's important to prevent these routing loops. We'll have a look at that also next time. Then we look at so-called autonomous systems. These are units in the internet that are managed under one authority, and the internet consists of many of these autonomous systems. And when you actually send a packet from one point in the world to another point, it typically traverses multiple of these autonomous systems until it reaches its destination. So we'll have a look at this, and we'll have a look at the interdomain routing within one autonomous system. So this means if you have a network under one authority, so this could be your internet service provider, for instance, or it could be a larger company that has this, or a university network, how is automated routing working in there? We look at distance vector protocols. So this is one family of these routing protocols that uses certain mechanisms to do that. We look at link state protocols. This is another family that does some mechanisms a little different, that improves from some problems that this one has. And we also look at internet-wide interdomain routing between those autonomous systems. And this is then the protocol we look at that holds this global internet together automatically. So there the information is exchanged into which directions packets should be sent, and when they're close to the destination, then the other protocols are used to address your host. So within your service, so this will be sending data to your service provider, while this will be sending data then within the service provider network to your concrete computer that receives it. And for this mechanism, we use path vector protocols, and the BGP is the protocol of choice there. Wow, cool. So as said last time, we'll continue with the next mountain. It's a little bit higher than the last one, and you will get even more details on how this routing and forwarding, this packet transfer actually works in the big internet. And then after next week, you're really a true master of the packet moving through the internet, and then we can even move further. So I'm already looking forward to welcoming you next time. As last time, relax a bit, think about all the things that you learned today when you surf the web. Maybe think about, okay, cool, now in the background these things are happening, so the MAC addresses are resolved, the IP addresses are used, and so on. And to me, this always makes it even more fascinating that everything works. And next time we'll see a little bit more of the magic and demystify it to really understand it and work with it. Cool. So I'm looking forward to seeing you next time, and wish you a very nice time. Until then, bye-bye.